Properties of logarithms. Logarithms have three basic algebraic properties that you want to be skilled in. And these are them. Let b, m, and n, capital M and capital N, be positive numbers such that b does not equal 1. Remember that if you have a base of 1 for a logarithm, it really doesn't do anything, okay? Or as an exponential, if you think about b being 1, raising 1 to higher and higher powers, it doesn't really do anything. So with that restriction, these properties do apply. Okay, so we're going to have a base that is not equal to 1. We're also going to have values that are inside of the logarithm called m and n. In the first property, which we refer to as the product property, inside of this logarithm, you have m times n. It's implied that there's multiplication between them. If you choose to, what you could do is separate those two factors by using two different logarithms. The trick is that when you separate them into their own logarithm, that you use addition in between them. Okay, it does not become log base b of m multiplied by log base b of n. It's actually going to be addition. Okay, now that's a choice you can make strategically as you're working a problem. You may find that you don't need it, or you may find that it's better to condense two things together. You may have two logarithms of the same base with different values inside of them. If they're being added together, you can go ahead and multiply the m and the n, whatever's inside of those logarithms, and create one. So sometimes you're separating, sometimes you're bringing together. Okay, now you can do the same thing with division. We call this the quotient property. If you have m over n, you can separate them into two logarithms using subtraction. Or if you have two logarithms of the same base that are being subtracted, you can take the two parts that are inside of them, you can bring them together as a fraction. You basically show it as division. Okay, and then the third property is called the power property. Okay, if we have a logarithm base b of m to the k power, so the k is being applied directly to what's inside here. You've got m to the k power. You are allowed to move that k value all the way out front as a factor. You can move it out here. Okay, or you can think backwards. If you have a factor that's out front, but it would be more convenient to have it inside, you can move it inside as a power to whatever's in that logarithm. So it becomes m to the k power. For example 1, what we're going to do is practice using our properties to expand out this logarithm. Okay, we want to take this and write it as log base b of m and a log base b of n. Some combination of those things. Okay, so the restriction here is that the only thing that we want in our logarithm will either be a capital M or an n. Okay, so inside of our logarithm, we've got the product of m and an n squared. Okay, I'm going to identify that product first and separate there. So I got that multiplication. I can separate that using addition. So I can rewrite this as log base b of m plus log base b of n squared. Okay, and I'm halfway there. This I like. Over here, I do need to deal with that 2. Okay, so using the power rule, what I can do is take that 2 and move it out front. And it's just going to sit right in front of that logarithm. So we get log base b of m plus 2 times log base b of n. And that's it. All right, same thing for example 2. We're going to take this logarithm and we're going to separate it so that we have log base b of m and log base b of n. And we don't have anything else inside of the logarithms except for the m and the n. Okay, we do have the square root of m cubed over n. Being that that square root is around all of it, we're going to deal with that first. But remember that a square root is the same thing as a 1/2 exponent. So we could imagine this as m cubed over n, all raised to the 1/2 power. So my first step is going to be using the power rule. I'm going to bring that 1/2 exponent out to the front. So we get 1/2 times log base b of m cubed over n. Okay, that division, we're going to separate that with subtraction. In addition to that, m cubed, we're going to be able to move that 3 out to the front using that power rule again. Okay, now here's the catch though. The 1/2 applies to everything. Okay, you might want to write it this way. 1/2, open parentheses, we're going to get 3 log base b of m minus log base b of n. And that's the answer. You do have the option to distribute the 1/2 in, but that wouldn't really be necessary for this exact problem. For example 3, we're going to think more of the opposite direction of the other two examples. What we have are two logarithms that are separate from each other, both of which are going to be base 10, right? This is the common logarithm. It does have that invisible base 10 here and here. Okay, so both parts do have the same base, which means we're allowed to use these properties. What we want to do is completely simplify this down. In other words, I want to condense this together. I want to bring everything together. I don't want to have a 45, a 2, and a 3. Hopefully, I can get this down to just a single number inside. Okay, what we're going to start with is taking that 2 and moving it into the logarithm. Okay, so we're going to have log 45 minus log 3 squared. It's going to be important that we move that 2 inside the logarithm so that we can then apply the quotient rule, which would be that division part. Okay, now 3 to the second power is going to be 9, which means that we can actually just call it 9. Okay, but in our next step, using the quotient rule, we're going to get the log of 45 divided by what will be 9, and this will simplify down to the log of 5. All right, and for example 4, we're going to try and use our properties to help solve for x in this equation. We got log base 2 of x plus log base 2 of x minus 2 is equal to 3. Okay, now one of the general approaches that we try and do when solving equations is isolate the x, but we happen to have x's in two different locations. However, using the properties of logarithms, we can actually bring those x's together. Okay, what we have here is addition, so we're going to use the product rule. We're going to rewrite the left side here as log base 2 of the product, let's use some brackets here, of the product of x and x minus 2. Then that's equal to 3. All right, so using our property, we were able to bring the x's together. Okay, what I'm going to do next is go back to an older rule. Okay, not one of our properties, but an older rule, and change this into an exponential function. Because right now, these x's are contained within the logarithm. Okay, and I'm going to need to remove that logarithm to eventually solve for the x's. The easiest approach here will be to convert it into an exponential. We can write this as 2 to the third power is equal to x times x minus 2. This, of course, is just 8. Over here, we can distribute. We ended up with a quadratic, okay? We'll go ahead and move that 8 over. So we get 0 is equal to x squared minus 2x minus 8. Then consider some factoring. What multiplies to give us negative 8, but adds to give us negative 2? That would be x minus 4, x plus 2. So the solutions from here, the solutions from our quadratic will be 4 and negative 2. However, one of these answers does not apply, because if you take it back to the logarithms and you think about the domain of a logarithm, there are certain values you can't have in there. Like if you were to graph this right here, if you were to graph that guy, log base 2 of x, you would get a coordinate at 0, 1. You'd also get a coordinate at 2, 1, which would be here. Then, when you start to draw this, remember that you got a vertical asymptote here, okay? So for everything that would be 0 to the left, you can't take those values, which includes negative 2. That can't be an input to this. It also can't be an input over here because that would give you negative 4 on the inside. However, 4 would be all right here, and 4 would also be okay here because you would get a positive 2. Okay, so it is possible in some problems that you create extraneous solutions because you move into a quadratic type solving. Okay, but this will be the one answer.
Later, blah.